Application based question on functions. That's what your topic is. Function modeling. So it's a linear function modeling. If you see number 14, Samantha is filling her car with petrol. The amount of petrol in the tank after t minutes is given by pt, petrol with respect to time. Petrol, how it is filling uh, after the time passes. 5 plus 10 t liters. We need to figure out P3 and T and how many liters of petrols were in the tank when Samantha started to fill. So the good questions. Just try to understand it and let me know the answer. Yeah, what is the context of the problem if you see, right? And what are you finding out? What is the meaning of that, right? So, for example, P representing the amount of petrol filled, right? And T representing by how much time, right? So, if I'm figuring out P3, it means in 3 minutes, how many liters of petrol is filled in the car, isn't it? So it's 5 plus 10 times 3, 5 plus 30, which is 35 liter, right? So interpretation would be in 3 minutes. See, or you can write like this whole statement, right? You can write like this, the whole statement, or you can rephrase it in your own. So I can say the amount, I mean, amount is how much? 35 liters of petrol, 35 liters of petrol is filled in the tank after 3 minutes. This is the interpretation. Are you getting this? स्टार्ट ही नहीं की है, 0-0 है। तो हम स्टार्ट थोड़ी किए थे, हम दिखा के छोड़ दिए थे। आपको स्टार्ट करना, ये वाला है देखो आइकन, इसको इसलिए यहाँ पर रखे हैं, ये खोलेगी। मान लो लूडो पुडो खोल दी। कहाँ है लूडो पुडो? इसे लूडो पुडो खोल दी तो यहाँ पे दिख रहा है ये वाला, इसको चालू कर देगी तो हो जाएगा। ठीक है, इसको चालू कर देगी ऐसे। ये वाला बटन है चालू करने का, और ये बटन है काटने का। ये चालू कर देगी तो शुरू हो जाएगा रिकॉर्डिंग। So, in what minutes the petrol tank is 50 liter? So, how do I solve this? 5 plus 10t, yeah, that's equal to 50. Alright. 50 minus 5, 45. T is 45 over 10, which is 4.5 minutes. Right, so I can say in 4.5 minutes, 50 liter of petrol, 50 liter of petrol is there in the tank. No, it will be not 10 liter. When she started to fill the tank, what was the time on that time? What was the time? Time was 0, right? We haven't started the timer. We haven't started the timer on that time. So it would be t is equal to 0, and when you find p0, you will find 5 liter. So 5 liter of petrol was there in the tank before she started filling, right? So p0 is 5 liter. So how many liters were there? 5 liters were there. Come to number 15. For a hot air balloon, right, the function ht gives the height of the balloon after t minutes. So I don't know whether you have done it or not. And it goes in the air and then comes down to the ground. The balloon, it- the balloon riding. It's a big balloon, and there is fire inside that. It's keep burning. Its graph is shown alongside. So this is the path of basically how much balloon is going in the sky at what height, and then it's coming to the ground. Obviously, it will not going to go in the sky forever. There is gravity, and there are certain questions related to that we can answer. Yeah, so here it is. If I just combine this with the graph, yeah, I'm getting that much. That's right. So the interpretation is after 30 minutes, the height of air balloon is 800 meters. Yeah, from the graph only we can determine this. So you can see at 600 the time was 20 minutes from the graph only. So B, right, we can write from graph T is equal to 20 minutes. For HT 600 meter, T is 20 minutes. Hmm. But isn't we can't know the height of the balloon in 10 minutes or 30 minutes? We already answered for the 30 minute. So it's basically the kind of for what to what value of of time we recorded the height. So it's kind of domain. So I can say for t greater than equal to 0 to less than equal to 80 minutes, we recorded the height of the balloon. What range of heights were recorded for the balloon? What is the max height? It is 0 to 900. 0 to 900. Here we have the two replacement for the x here. One is 1, another is 2. And we have the values of y at that point. Are you getting this? So f1 is a times 1 plus b upon 1, and the value for that point is 1. So what is my equation? A plus b is equal to 1. On the other hand, we have f2. So 2 times a, b upon 2, the value is 5. So it's 2a plus b by 2 is equal to 5. 2 times 2, 4, plus b overall 2 is equal to 5. So what is the equation I'm getting? 4a plus b cross multiply 5 times 2, 10. This is equation number 2. This is equation number 1. Can you solve this? The two equation for a and b? Yeah. Okay, so did you get the value of a and b for this one? So what you can do here, I can subtract equation 2 from 1. So it will be 4a minus a, and b minus b will cancel out. 10 minus 1, which will be 9. So it is 3a is equal to 9. Hence my a value is 3. My a value is 3. Now to get the b value, I can substitute this a value in either of the equation, and I'm going to get the same b value for that. So let's say I substitute in 1. 3 plus b is equal to 1. So b is 1 minus 3, which is minus 2. So this is the b value. A is 3, b is minus 2. Okay, A is 3 and B is -2. Now you can solve the number 17 in very same concept. T0 is -4, T1 is -2, T2 is 6. So T0 means what? A times 0 square B times 0 plus C is equal to -4. So I'm directly getting the C value from this equation. T1 is A times 1 square plus B times 1 plus C is equal to -2. So it is A plus B plus C is equal to -2. Since we already have the C, so I'll do A plus B plus -4 is equal to -2. So it is A plus B -2 plus 4 is +2. So this is one of the equation we created. For T2, it is A times 2 square B times 2 plus C we already have, which is -4. That's equal to 6. So it is 4A plus 2B, 6 plus 4 is 10. Now we again have the same two equations to get A and B. A is equal to 2 minus B. So if I substitute this A value here, it is 4 times 2 minus B plus 2B is equal to 10. So it is 8 minus 4B plus 2B is equal to 10. So it is 8 minus 2B is equal to 10, and hence B have the value of B, which is minus 2B is equal to 10 minus 8, which is 2. Therefore we have the V value as -1. Right, so we have B value. So A value would be what? I'll substitute this B value here. So it's 2 minus -1, which is 3. So we have A, we have B, we have C. Yeah, let me resize it. Now come to our next topic, that is domain and range of function. Domain and range of function. So just we understood the relation between two variable x and y, and we call one of the variable as dependent variable and other variable as independent variable, right? The one which depends on independent. So we generally say x as our independent variable, right? Independent variable. We call it independent variable. And This we also call it the input section. This also call it input section, and hence this is known as domain of the function. So by definition I can say all the possible values of x is known as domain of function. Whereas on the other hand, y is known as our dependent variable, which we also call that output of the function. This is going to be our range. So we call it all the possible values of y is known as range of the function. Right. All the possible values of y is known as range of the function. Okay, we have seen this in our, so you can see here from the graph we can also understand. So for example, this is the function we have given. So what is the domain? Domain would be from this starting point to this starting point. This is the all possible x values of this function. Domain is the relation, the set of the values which is the variable on the horizontal axis can take. The variable is usually x. Whereas the range is the minimum y to the maximum y. The minimum to maximum y is the range. Range is the relation, is the set of values which the variable take on the vertical axis. The variable is usually y. That is the range. Okay. Are you getting this? Now, how do we write in terms of inequalities? It's also important. How do we write it in terms of inequalities? So let's say if there is some function given to us and the domain of that function we have to write all the numbers which is greater than and equal to 3. So you can see how we notate it to the interval notation or how it looks like on the number line and what is the meaning of that, and usually we use this sort of set notation to write that domain and range. And what is the meaning of that? It is less than 2, so 2 is not included in the solution, and this is minus 2 to 1, whereas minus 2 is not included, 1 is included. So on the number line it looks like this, and this is less than equal to 0 and greater than equal to 4. So how it looks like in the number line, less than 0 and greater than, so in between 0 to 4 there is no domain. For the different graphs, how the domain looks like. You see the graph number one, this is graph between time and the charges. So it could be any situation you can get between the, let's say, the parking charge or the fare charge on riding on the car. So but how it looks like, if you see the functions, the lines are very distorted. The lines are like very distorted, and it looks very, tedious to get what it is, right? So to understand this, we need to focus here. There is one point on every line which is hollow, completely white color, and the other point is it's dark, it's filled with the color, right? So what do I understand? Uh, we can understand this as, at that point, for example, if I take the 6, at 6 the value of the charge will be this much, whatever the number here, not this much, because this is not included at 6. Similarly, we understand at 9 the value of the charge is this much here, very less than 20, but not this much, which is hollow here, right? I hope you're getting it, right? So it is like, for example, from 12, at t is equal to 12, the price, let's say somewhere 20.2 or 20.3 dollar. But from 12 onwards, like 12.1 hour or 12.2 hour, the charge will suddenly hype up to almost more than 25. It's like 28 or 29 dollar, and this will go till 24 hour. So time boundation, I understand, time is from 0 to 24, and so goes to the fare also. It's 0 to 0 to 30 almost. In fact, they have written the range is 28, so the highest is 28. Yeah, and at 12 hour the charge is not 28. This is here. So before 28 it was 22. So at 12 hour the charge is 22. Yes, after 12 hour, let's say 12 hour 2 minutes, 12 hour 1 minutes, 12 hour 5 minutes, which is just greater than 12 hour, the charge will shoot up to 28 pounds. That's what the graph is showing. Are you getting this? On the other hand, if you see the graph number 2, it's very clearly visible, like from where to where the graph is going. The arrow representing that graph is not ending at any point on that side. It's going, 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 going. So I can see for the domain, I'll check what is the initial point of x. The initial point of x is -1, and I'm not going to get any final point because this graph will not going to end. So it is all the x value just greater than equal to -1. This will be my domain for this function. Same goes with the range also. So the lowest y value here is -3, and there is no ending of the height on the right hand side. You can see it's going up and up. So y is also greater than equal to -3. Y is also greater than equal to -3. That's what the range is. Okay. On the other hand, if you see the other two types of graph, like parabola, the quadratic and the rational one. So in quadratic, we we don't have any restrictions in the domain until unless it is restricted in the graph. Otherwise, we don't have any restrictions in the domain. So if you see the parabola, the parabola is having no ending in either left side or the right side. So the domain is basically belongs to entire real number. So there is no restrictions in the domain until unless it is restricted in the question. They restrict it somewhere. It's not going to give you that arrow. Instead of that, they will say there is point here. So in that way, it is restricted, but it is not restricted here. Although the range is restricted because of turning, because this such type of graph turns after a certain point, and they don't go beyond that. So for example, here it's turning at 2 comma 1. So what is the y value here? The y value is 1, and it means it is not going beyond 1 because it is going down. So the range is all y less than equal to 1. Are you getting this? On the other hand, if you
Yeah.
see the rational function, the rational function in which we have asymptote here. The asymptote is like the vertical one and the horizontal one. The vertical one is this dotted line. You can see x is equal to 2. So again, the domain of the such function is all real number because it's going all the way left, all the way right, but only not exist at x is equal to 2. So it's right x such that x not equal to 2 and all real number. X can take all values except 2. Same goes with the range as well. Range will also going down and going up, but except one value, that is y is equal to 1. So range is also except y is equal to 1, it is all the values of y. Are you getting this? Let's figure out domain and range of these following functions. Less than equal to 3 because it's going down, right? It is not going up, so we can say greater than equal to 3. It's less than equal to 3, right? It's the, if you see this is going down, so it will take the negative values after certain time. 2 3 1 0 minus 1 minus 2 minus 3, isn't it? If you see this line at this point, at this point, what is the y coordinate? These are the less than 3, right? Yeah, I am writing x in between -1 to 5 because I can see here this point is not filled with the black completely, so we not need to include -1, right? Same goes with the y. I'll not include 1, and on this side I'll include 3, so it's bounded between 1 to 3. That's the range. Here the domain will be all real number except x not equal to 2. Similarly, y is also all real number except y is not equal to -1. Okay. Come to number D. So I can see the domain is here all real number. There is no restrictions with the domain. It is all real number. But for the range, it is between what? I'll not include 0 because it is not going to touch that 0, but less than equal to 2. Yeah. And this is the parabola. So I told you parabola. This is again the domain is all real number. But the restriction with the range, that range is greater than equal to -1. And this is again the parabola coming down, concave down. So again the domain is all real number, whereas the range is less than equal to 6 1 by 4. Are you get? Yeah. See, what is the turning point y coordinate? What is the turning point y coordinate? Tell me. Yeah. So half is x coordinate and 6 1 by 4 is the y coordinate. Right. And if you see this graph, tell me, will this graph go beyond 6 1 by 4? Do we have any y value beyond 6 1 by 4? No, it is coming down from there. So 6 1 by 4 is the highest y value. Right, that's the highest y value. And from there it is only coming down. Right. Are you getting this? Great. So practice the questions from the exercise. You have a lot of similar questions like this in your exercise 3C. Okay.